In this tutorial, you will be introduced to stock models and boundaries, learn how to clone a toolpath, and see how to create a rest machining or rest roughing toolpath. The first toolpath we created was used to rough out the majority of the material from our stock. We are now going to tackle the remaining areas of excess stock on the part using a rest machining toolpath. Let's rename our first toolpath as roughing to help us identify it later, and then look at the remaining stock on the part. Autodesk Powermill has the capability to build a model which represents the stock material left after each machining operation, called a stock model. Stock models can be referenced by subsequent machining operations, producing toolpaths that are as efficient as possible, continuously cutting material whilst minimizing any fresh air cutting. To generate a stock model, again we can create one either from the Explorer tree or the Stock Model ribbon tab. Create a stock model. Let's call it Stock Model and leave the rest of the settings as default. The stock model is initially empty, so we need to add toolpaths to it in order to build up the stock image. Add the roughing toolpath either via the right-click menu or from the ribbon. Note that the toolpath is now in the stock model list. Calculating the stock model will generate the stock image. Items in the Explorer tree can have their visibility modified by using light bulbs. Let's hide the roughing toolpath to see the stock model more easily. By default, the stock model is wireframe, but can be shaded for better clarity. We can also view the rest material by selecting the option to do so. Hiding the model makes this easier to see. Reshade the model. Our stock model can now be used as the reference for subsequent operations. Although we could create a rest machining toolpath in the same way as shown previously, in this instance we're going to clone a toolpath instead. If we revisit the roughing toolpath settings, we can create a clone directly from the toolpath settings form. By creating a clone, we obtain all the settings of the previous operation, allowing us to change the minimum number of options. Because we made edits to the toolpath, a warning informs us of this case. Choose OK. Some of the values we want to keep, others will be changed. Let's rename the toolpath as Rest Roughing. From the Tool area, let's change to our 20mm end mill. In the Limit section, we will define a boundary to limit the toolpath to stop it working down the sides of the part. Select the last icon for the user-defined boundary. In the Graphics area, select the bottom surface of the part and then press the Insert Model icon to create a boundary. Accept to close the form. This boundary is active and so will be used for the toolpath. In the Model Area Clearance section, we will check the option to Rest Machine. Note a new section appears in the form to define the rest parameters. Since we are using a smaller tool, and we are trying to remove the material left by the previous operation, we will adjust the step over to be 10mm and the step down to be 1mm. In the new Rest section, we can choose our reference. Rest machining can reference either a singular previous toolpath or a stock model, the latter of which has the advantage of effectively allowing multiple toolpath references. Two key settings to change here are the Detect Material Thicker Than and Expand Area By settings. The Detect Material Thicker Than setting tells Powermill to ignore rest material that is thinner than the specified threshold. This helps avoid thin regions being rest machined, such as those caused by cusps from the previous toolpath, where the benefit of a second cut is negligible. The Expand Area By setting will expand the rest areas measured along the surface by the distance specified. We will set 0.3mm and 4mm respectively. The final option we will modify is to switch off the Unsafe Segment Removal tool, since this tool is center cutting. Hit Calculate to generate the toolpath. This toolpath will take longer to calculate, but the toolpath produced will be efficient, saving overall machining time. We can add this new toolpath to our stock model and calculate it. Once calculated, we can save the project again to complete this tutorial.